Was that yesterday? That was yesterday. Gosh, my day, I said to my husband last night, doesn't it feel like Thursday? He's like, I wish it was Thursday. Yeah, me too. It was Tuesday. Just a busy week. So yesterday we talked about the graphs that look like a line and the graphs that look like a parabola. When does it look like a parabola? The U shape, if it has what in the equation? X squared, right? If it has x squared in the equation, it's the parabola, okay? Today we're going to talk about absolute value, and that is if it has the bars, right? The absolute value bars, like this, okay? Whenever that happens, it is always a V shape, okay? It can be a V or an upside down V is fine, but it's got to be a V shape. It will not be a straight line, and you're going to be tempted at times to make it a straight line. It's got to be a V. Okay, so the parent function is f of x equals the absolute value of x. Couple things that you need to note in here. First of all, this point right here that I'm attaching to the green arrow, okay, that's called our vertex, right? So we're going to have a vertex that we're addressing a lot with these types of graphs. And then the other thing, and this one hasn't really been discussed much, but you're going to see it a lot in Algebra 2. This line right here, in this case, it's our y-axis, but it's not always the y-axis, okay? What we call it is the axis of, anybody? Symmetry. Okay, the axis of symmetry. And oftentimes we'll just call it AOS. So if you see AOS, we're just talking axis of symmetry. Basically what that is if I took a piece of paper and I had this graph on it and I folded the paper on that line, my two parts of my graph should match up perfectly, right? They're symmetrical. It's like a butterfly, right? Butterfly's wings, you have the body and then the wings. If you folded the butterfly's wings, they match up perfectly, hopefully. So that is absolute value, has this axis of symmetry, where we could match up both sides of our graph perfectly. When we're trying to figure out what makes sense for absolute value, we often will use a table of values. So like most common, it's -2, -1, 0, 1, and 2 that will get plugged into a function to see what our graph actually looks like. So if you have to graph something, those are your 5 numbers. Try those numbers, see what happens. It will usually give you a decent idea of what's going on. Okay, so let's talk about this. If I plug a -2 into my parent function, so we're saying f of -2 equals the absolute value of -2. What do I get? What is the absolute value of -2? 2, right? If I plug in a -1, what's the absolute value of -1? 1. What's the absolute value of 0? 0. Absolute value of 1, and the absolute value of 2. 2. Okay, so those are all your points. Notice 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. Okay, so that gives you that V-shaped graph. Okay, here's the part that's review. This should feel very familiar to you. We talked about the vertical and the horizontal translations that the parabola did and that the lines did, right? The linear functions. Now we're going to talk about those same translations with absolute value. They're exactly the same. Nothing changed. Okay, so you have this in your notes from yesterday. It's the same thing in your notes today. The thing to keep in mind is this side will be the same as what you expect, okay, or the expected shift. What did I call it? Typical. I called it typical. The typical shift yesterday. In other words, if this plus k is outside, we shift up. If the minus k is outside, we shift down. Okay, the only difference now is we have absolute value bars instead of an x squared or just an x. The other side, if we have this minus inside the bars, we typically would shift left, right? In this case, we shift right. If we have a plus, we shift left. So this is going to be opposite of what we would expect. Okay. So that should be nothing new. Any questions on that one? Thank you. At all, translations. Okay, reflections. We talked a little about reflections before, right? That was yesterday's lesson. When it's the opposite of the absolute value of x, we reflect over the x-axis. So when we change the whole function, right, the opposite of that, we flip over the x-axis. What happens is this ends up just flipping upside down, right? If I have an absolute value graph that looks like this, then what's going to happen when I flip over the x-axis is it's going to look like this now, right? It's just going to flip over, okay? When I just take the opposite of the x, that's going to flip over the y-axis. But think about this. For the parent function, if my parent function is this, and I flip over the y-axis, what's my new function? It's the exact same thing, right? What was on the right moves to the left. What was on the left moves to the right. I get the exact same function back. So just keep that in mind when you reflect over the y-axis for the parent function, for the original function, you would get that same thing back. Okay, then we're going to talk stretch, or sometimes it's called a compression. Stretches and compressions are just stretching or compressing, right? So you'll see those words kind of interchangeably. Don't let them freak you out. It's just saying like how wide or how narrow is our graph going to be. For compressions, there will be this A term out in front, or stretch, okay? There will be this A term out in front. And essentially, we're treating that like a slope, okay? What happens is we take that number, it'll be a plus or minus, okay, positive or negative A, and then over 1, right? That's how we always treat a whole number as a slope. The tricky part is if it's a fraction, it's still that fraction over 1, okay? So I'll explain that as we go, but just know that we're kind of treating this A out in front as a slope, okay? And that's what's going to stretch and compress, and I'll show you those in just a minute. Okay, so let's do it. Let's do a few problems here. First of all, if you look at example 1 and it says graph the translations, what shape is every one of these graphs going to be? A V, because every single one of them has absolute value, okay? So I'm going to do the first one for you. Actually, I'm going to do the first 2 for you, and then I'm going to have you try the next 2, and those are the harder ones because there's multiple things going on, but I believe in you. So letter A, it's the absolute value of x plus 3. Where am I moving for that? You're going up 3 from the parent, right? So from 0, 0, 1, 2, 3 is going to be my point here. And then here's the deal. There is no number out in front. So essentially, it's a 1 out in front for your A value. So that means we're going up 1 over 1, up 1 over 1, and I get this graph. Okay. What's the difference between A and B here then? Because now B is still the absolute value of, now it's x plus 3, but our plus 3 is inside the bars. Where are we moving now? It's not down. To the left, opposite of what you would think, right? Normally we would say, oh, it's plus, we should go to the right. We're actually going to the left to make it a 0. So 3 to the left would be here. And again, there's this imaginary 1 out in front. So my slope is up 1 over 1, up 1 over 1. We know it's V-shaped. So it's going to look something like that. Okay? So here's what I want you to do. I want you to try C and D for me, and then chat with your neighbor, see if you're getting the same thing, and then we'll chat it out together in just a minute. Give it a go. Look at my cute mug, you guys. Isn't this so cute? I love this mug. Have any of you been to Mount Herman before? You should go. It's amazing. Have you been to Mount Herman?
No.
Oh, you have a question? What's up?
Can you go back to the second graph?
Mm-hmm. No one's been to Mount Herman? Oh, You guys are missing out. Has anyone been to Hume Lake? I feel like it's kind of like Hume Lake. There's no lake though, but you're in the Santa Cruz Mountains and you get to go like to the beach and the boardwalk but it's family camp. Okay. Did you talk to your neighbor? Did you get the same answer as your neighbor? Okay, so tell me on letter C, what did you do? Where did you go? Down 4. And then what? To the right one. Right? Opposite of what you would think when it's inside, right? Because minus would normally be to the left. So you go opposite of that and go to the right. So to the right one, and then 1, 2, 3, 4 down is right here. Do you have an A value visible? It's a 1, right? There'd be this 1 out in front. So that's just up 1 over 1 and up 1 over 1. So your graph will look like this. Okay. Oh, guys, when you submit your homework, some of you have been saying like, I'm turning it in on graph paper, but you're not seeing it. Did I show you yet how to show that you're on graph paper? When you do the sharrow, you know what the sharrow is? The little box with the arrow up. It's called a sharrow. When you click on that, it'll say paper, and you need to click the little toggle to on. Yes? You know what I'm talking about? If you're doing it on like the grid paper, sharrow, and then paper on, and it will show me your grid paper then, okay? Okay, what did you do for D? Where are you moving? Down 1. To the left 3, yes. So if we go to the left 3, 1, 2, 3, and down 1, you should be here. Your A term is still a 1. There's no number out in front of our absolute value bars. So up 1 over 1 on all of those, and it looks like that. Fantastico, right? You love graphing absolute value? I love graphing absolute value. Okay, so compressions and stretches. We're going to throw this into the mix now. Here's what I want you to remember. Maybe you want to write this up in the notes where we talked about stretches or whatnot, but I'm just going to write it here since that's what we're moving on to. When you are graphing this, okay, when your A is a fraction, it's going to widen your absolute value. Okay, when it's a fraction, it's going to get wider. When it is a whole number, it's going to be more narrow. Okay, which makes sense. We're treating it like a slope, right? So if I go up 1 but over 4, like with 1/4, that up 1 over 4 is going to leave me wider. Whereas if I go up 3 but only over 1, that's going to keep me real narrow, right? So whole number is going to be more narrow. A fraction is going to widen up a bit. Okay, so graphing compressions. Where does this one shift in terms of up, down, left, and right? It's a trick question. It doesn't, right? There's nothing behind our X that tells us go up, go down, go left, go right. It's 0, 0, okay? So our vertex is still 0, 0 on this one. This, however, that's our A term. We need to treat that as a slope, which would be 3 over 1. So from my vertex, I'm going to go up 3 to the right one and up 3 to the left one. And that's really all you need. You can keep going if you want, but all you need are those two, and then draw that graph in. Okay, and it's a V, it's not a U. So make your lines straight on these, make your lines curved on the parabola ones. Okay, so, oh, you know what? I told you the wrong thing. I was thinking of a different lesson. You don't have to put the fraction over 1. The fraction is your movement. Good thing you didn't know what I was talking about at that point. Ignore that. Letter B here. When you have y equals a negative 1/2 times the absolute value of x, what's your vertex? 0, 0, right? There's nothing behind our x to tell us to shift up or down or left or right. where are you going to move for your next 2 points? Down 1, right? Negative 1/2, you're going to go down 1 over 2, and then down 1 over 2. Notice what happened. The fraction is wider. The whole number is more narrow, right? So you can just tell the difference with that. Okay. Questions, comments, concerns? Yeah, Jada.
So I'm confused with the so you saying you have to fraction?
No. Don't worry about me saying I said it wrong, because I said it wrong a long time ago and you probably didn't know what I was talking about at that time because I hadn't explained anything to you. So just ignore it. You're fine. Everything I just said is the way to do it. Okay, general form. Now here's where we put it all together, and there's lots of pieces, and you just need to take your time because we just did all the pieces individually. Now we're going to put all those pieces together, which feels a little overwhelming, but it's not, because you know all the pieces, okay? You know all the parts of it. So the general form that we're going to use is this equation right here, okay? This number, this h, and this k outside are where your vertex is going to fall, right? If I move 3 to the left and 4 down, I'm at 3, negative 4, okay? So that's going to be our vertex, the h and the k. Our axis of symmetry is always, always, always x equals h. You're going to be tempted at times to just say our axis of symmetry is h. But an axis of symmetry is a line, okay? And in order to name a line, it has to be an equation. So make sure you're putting x equals, and then this will be some number that we plug in, okay? The same number that you see in your vertex and right here, okay? So let's break this down one piece at a time. I think you're gonna love it. I love it. So find the vertex, find the axis of symmetry, and then graph it. Where you have to be a little bit careful here is notice your general form is subtraction, okay? It's x minus h. So if this is x minus 3, what is h? Positive or negative? It's positive, okay? Because the equation is subtraction. So x minus whatever number it is. So this right here is our h, okay? That's the 3. What's k?
4.
A positive 4, because that one is plus k. So this is my k. So if my vertex is 3, 4, you can go ahead and plot that. 1, 2, 3, 1, 2, 3, 4. Okay, there's my vertex. Now think about this. If you can't remember the axis of symmetry, but you do know the vertex, you can very easily find the axis of symmetry, right? The axis of symmetry will always fall on your vertex. So without even thinking about numbers right now, I should know that my axis of symmetry is right here. Okay, haven't even graphed it, but I should know where my axis of symmetry is. This is my AOS. Can you tell me the equation of that line? Remember, a vertical line is always x equals or y equals? X equals, okay? And what is your x value there? It's 3, right? So all you're doing for this axis of symmetry is saying, this is my x and it equals 3, right? X equals 3 is going to be that line, right? That's this right here. X equals h, x equals 3. Okay, next step. Where do my next points need to move? Look at the equation. 2 up, to the right and to the left 1, right? The reason being, we have an A of 2. Okay, so that's your slope. We're going up 2 to the right 1 and up 2 to the left 1. So I get this as my graph. That's not so bad, right? It's a lot of information, but you just have to take it one piece at a time and it's fine. Yes.
So why is it 2? Because of the 2 in front of the x.
This 2, that's your A value, that's your slope, right? This right here, in the general form, we're treating that like our slope of our line. Okay, so you try letter B. Do all those pieces. Figure out what is my vertex. Be careful with positives and negatives because those go wrong and then everything goes wrong. See where you end up. Try to graph that. I love this lesson, you guys. Love it. Okay, I'm going to lay out the general form right above here. Y equals A times the absolute value of x minus h plus k. What did you get for your vertex? -4. -1. Good. So opposite of what this looks like, right? If it looks positive, it's negative. If it looks negative, it's positive. So -4, -1 is your vertex. What's your axis of symmetry? X equals -4, your x value, your h value. Okay, so we plot that. -4, 1, 2, 3, 4, -1 is right here. Our axis of symmetry, and I do want to see the axis of symmetry. Make sure you put a dotted line in there. Okay, where are we moving to get our other 2 points that we need? Down 3/1, right? This is like a -3/1. So 1, 2, 3 down over 1, 3 down over 1, and your graph should look like that. Did you get that? Hopefully. All right. Then we're going to flip it around. What is the equation of this absolute value? So here's what I would do if I were you. I would say this point right here, 1, 2, 3, 1, 2, 3, 4, that's my vertex. Okay, so name it, 3, 4 is my vertex. Then figure out what A should be. What would A be on this problem? Look where you have other points. A point here, a point here, a point here, right? We're going down 2 over 1. What's A? -2, right? Down 2 over 1. So -2 will be my A. And now you put it into the general form. So remember, general form is y equals A times the absolute value of x minus h plus k. So we plug it in. Y equals -2, absolute value of what? -3, plus or minus 4? Plus 4. Okay, so that would be your equation. Did you try the second one? Try B. What do you get there? I got the vertex by just naming this point. So that point is 1, 2, 3 to the right and 1, 2, 3, 4 up. So that's the point 3, 4, right? And then I just dropped that in here. So x minus whatever my h value is. So x minus 3 plus 4, okay? And then the 2 here. All right, what did you get for your equation on B? Y equals
-1. Oh, what was the
you can give me the vertex. What's the vertex?
Is it -1 and -5?
-1, -5, yes. What did you get for A? Where'd you move? From the vertex. 1, 2, 3 up, 1, 2 over, right? So A would be 3/2. So what's your equation? Don't all shout at me. Okay, so it's x minus a -1 is what? X plus 1 minus 5. Good? We got that?